Welcome friends in my video lecture series of theory of machine. Today I discuss the velocity analysis of a rigid link or velocity analysis of a kinematic chain or velocity analysis of a mechanism. First I show you the model of two types of mechanism. One is slider ring mechanism and another is 4-bar linkage mechanism. Then I discuss the method of velocity analysis.
This is a slider crank mechanism, and here the rotating link is crank, and with the rotating link the connecting dot which connect, and the connecting dot is connect with another link and which is sliding on the sliding link. So this is the slider crank mechanism model. Now I am going to show you a 4-bar link mechanism. Here the small link that is called crank, it can rotate, and this link is fixed at 2 points, and the opposite link is called coupler. Now the link is rotate, crank is rotate, and this is the 4-bar linkage mechanism. Now I am going to discuss the second chapter, that is velocity analysis. Velocity analysis in graphical method. There are so many methods to analysis velocity of a mechanism, but mainly two methods are very important. One is relative velocity method, another is instantaneous center method, to determine the velocity of a mechanism. So first, today our lecture is limited to relative velocity method. Then I discuss instantaneous center method. Here we discuss velocity analysis of a kinematic chain. So before going to discuss the velocity of a kinematic chain, first I discuss the velocity analysis of a rigid link, of a single rigid link. Then we discuss the velocity analysis of a mechanism or kinematic chain. So this is the rigid link. Now first I show you the model, then I discuss the velocity analysis of a rigid link. This is the rigid link, and this is the fixed point which is fixed on the board, and it can rotate with respect to a fixed point. Okay, suppose the linkage initial position of this link is this, then the link is rotate, and the next position of the link is suppose this. So within the time interval delta t, it's generate the angle theta, and the angular velocity of the link is omega, and the length of the link is r. So that is length of the link r. Now we know velocity v equal to omega into r. Omega is angular velocity, r is the radius or link or length of the link, then velocity v equal to omega r. And the link is rotate clockwise direction with angular velocity omega. This is called arc length. Now what is the direction of the velocity? We know the direction of the angular velocity, that is clockwise, but direction of the velocity, that is tangent to the position. Here the link position is this, then in this point the velocity is tangent, velocity direction is tangentially, and if the link is rotated clockwise, so the direction is clockwise direction, and this is 90 degree, the angle is 90 degree. So the velocity generate an angle with the length of the link 90 degree. And we can determine also the velocity of any point of the link at the end or in the middle position of the link. Suppose we can, this is the middle position of the link, we can determine the velocity at point B, at point C, and at point A, anywhere from A to B. Now here the point A, point B, point A is fixed point, and here the rotational pair is exist. The link can rotate with respect to the point A, rotational pair, A is fixed point, now the velocity, the angular velocity is clockwise direction, and the velocity is tangentially from the point B. So this is the arc of the angular velocity. and the velocity direction is tangentially from point B, and this is (90°) with the length AB. We know, so the velocity of point B, we find the velocity of point B with respect to a reference, a fixed point, that is A. The velocity of B with respect to A, VBA, that is denoted as VBA, velocity of B with respect to A. As we know, the velocity is a vector quantity, so it has direction as well as magnitude. So the velocity direction of the link AB at the B point, either clockwise, either right hand side or left hand side, it depends the rotation of the link AB. If the link AB rotate clockwise direction, then the velocity direction is right hand side. So here omega is the angular velocity which is rotated clockwise, so here the velocity of the direction of the velocity is in this direction, and the magnitude of the velocity is, direction is known, the magnitude is omega into AB, length AB. Omega is the angular velocity, as you know, V equal to omega R. Here R is the length of the link, that is AB. Now the velocity diagram of the link AB. We have to find the velocity diagram of a mechanism. Also we have to find out the velocity diagram of a link AB. Suppose this is the fixed point, the point is A, and the direction of the velocity is in this direction, in right hand side direction. So the velocity direction is draw from the point A in this direction, that is parallel to the velocity direction, or also perpendicular to the link AB. Now if omega equal to 5 radian per second is given, and the length of the link is, suppose, 6 centimeter, AB equal to 6 centimeter, so the velocity V equal to omega into AB, and omega equal to 5 and AB 6, so the velocity of V equal to 5 into 6, that is 30 centimeter per second. Now to draw the velocity diagram, we have to consider a scale. Let 30 centimeter per second equal to 2 centimeter scale. And we locate 2 centimeter on the velocity diagram, that is equal to 30 centimeter per second. So 2 centimeter, and the direction is in this direction, so this is equal to 30 centimeter per second. Now if we have to say determine the velocity of any point of the link AB, then suppose this is the point C. First we determine the velocity of point B, then I determine the velocity of any point of the link AB. and velocity of C with respect to a fixed point, that is A, velocity of C with respect to A equal to same omega into the distance AC, and here AC is given and we have to find the velocity of C with respect to A on the link AB. So to find the velocity we use two relation, V of BA equal to omega AB and V of C equal to omega AC. So V of BA by V of CA equal to omega into AB by omega into AC. Omega cancel, so VBA by VC equal to AB by AC. Sorry, here AC is given, we have to find V of CA. So V of CA equal to AC by AB into V of BA. So we can find from the relation V of CA within the link, any point of the link. Now to locate the V of velocity of C with respect to A, that is velocity of C, we have to consider the scale. From here, that is velocity of B with respect to A equal to 30 centimeter, and AC is here given and AB is given 2 by 6 and V of BA equal to 5. So V of CA equal to 10 centimeter per second. Now we consider here 30 centimeter per second equal to 2 centimeter scale. Ten centimeter per second equal to 2 centimeter divided by 30 centimeter into 10, so that is 2 by 3 centimeter scale. That means 6.6667 centimeter. So if we locate on the graph on the velocity diagram 0.667, this is the velocity of point C. 0.667 means 10 centimeter per second velocity, that is velocity of C, velocity at the point C. Now I discuss the velocity of a kinematic chain of a mechanism. Velocity analysis. This is the 4 link mechanism. Here suppose we have to say find the velocity at the point D with respect to fixed point AB. AB is a fixed point. fixed point. So this is considered as single point. If AB is a fixed point, so this is considered as a single point. These 2 points is considered as a single point. So velocity of D with respect to fixed point A we have to find. So velocity of D with respect to A equal to, we can write velocity of D with respect to point C and velocity of C with respect to point A. So velocity of D with respect to C, V DC, plus velocity of C with respect to A, V CA. Also it can be written as AD equal to CD plus AC. The velocity also can be written as in this way. Velocity of D with respect to B is V dB equal to also velocity of D with respect to C plus velocity of C with respect to A, if A and B is a fixed point. A and B are the fixed point. Now we have to find out the velocity, suppose on the link CD, and the point is F. So velocity of DC divided by velocity of FC equal to, you know, CD divided by CD upon CF. So from here we can find the velocity of F with respect to C. Velocity of F with respect to C we can determine from the relation. Now if we have to find velocity of F with respect to A, then we know velocity of F with respect to A equal to velocity of F with respect to C velocity of F with respect to C plus velocity of C with respect to A. Then we can find the velocity of F with respect to a fixed point A. Now if suppose this is the ternary link, the link CD is a ternary link, and we have to find the velocity of point G. Here point G is offset point. Velocity of G with respect to point A or velocity of G with respect to point B we have to find. So velocity of G with respect to point A equal to velocity of G with respect to point C plus velocity of C with respect to point A. A is the fixed point. Now if the velocity of G with respect to A equal to, also you can write velocity of G with respect to point D plus velocity of D with respect to point B, as A and B point is same point, single point, so we can write it. Now the velocity diagram of Ford link mechanism. First I draw the mechanism here. AB is the fixed point, CD here, AB is the fixed point, there is a single point, and AC link is 45-degree angle with the fixed link AB is given. So we have to find out the velocity of C with respect to point A, and we know the velocity is perpendicular of link AC and which is passing through from point A. Velocity of C with respect to A, that is passing through point A. So I draw a line, parallel line of the velocity direction or perpendicular line to link AC. Now we have to draw the velocity diagram of at point D. So the velocity of point D with respect to C, the velocity diagram, the direction of velocity which is passing through C, and velocity of D with respect to point B, the velocity diagram which is passing through B, and the two lines intersect where, that is the point D. Here velocity of D with respect to point C passing through the point C, perpendicular line passing through the point C, and velocity of D with respect to B, the perpendicular line which is passing through point B, respect to B, so passing to point B, respect to C, passing to point C. So these two lines intersect where intersect, that is the point D. Intersect each the velocity of point D. Now here velocity of D with respect to C, the perpendicular line which is passing to C, and in the velocity diagram I draw the parallel line of the velocity direction, and velocity of D with respect to point B is perpendicular direction passing through B. I draw the parallel line of this velocity direction or perpendicular line of DC or DB. So these two lines intersect at the point which is D, that is the velocity of point D. Now here AC is the crank and the angular velocity of the crank is given us, that is given, and we know the velocity equal to omega into distance AC. omega into distance AC. Suppose the omega value is 5 and the AC value is 5, AC is 5, so the velocity of the crank is 30 centimeter per second. Now we have to consider a scale. Suppose 30 centimeter per second equal to 4 centimeter scale. I consider it. And here this line is 4 centimeter. This line is 4 centimeter. And now if we measure from C to D, we can find the velocity of D with respect to C. Suppose C to D give some measurement 3 centimeter or 2 centimeter, and 30 centimeter means 4 centimeter means 30 semi per second velocity. So 2 or 3 centimeter means we can find what is the velocity of D with respect to point C. Line DC is 3 centimeter, so velocity of D equal to with respect to C 4 divided by 30, so 30 divided by 4 into 3, so that is the velocity of point D with respect to C. Also you can determine the velocity of point D with respect to point A if we measure the distance dA, and then we can get the velocity of point D with
Next
respect to A.
lecture I discuss the example of derivative velocity method. Then the lecture will be totally clear. And if you like this video, please like it and subscribe my channel for more videos. Thank you friends. Thank you.